So today, guys, we're going to continue our graphing in vertex form. Again, the reason we call it vertex form, well, it's super easy to look at it and pick out the vertex. We just look for our left and right transformation and our up and down transformation, and we've got the coordinates of our vertex. So today, as you look at our first example, it might be like, Miss Golly, that looks exactly like what we were just doing. You asked me for transformations, vertex, axis of symmetry, concave up or down, domain and range, and you're asking me to sketch the graph. You're right, but we have a couple new pieces today. Instead of us just jumping to the calculator and creating a table, we're actually going to find some of those other points on our graph ourselves by solving some equations with square roots like we did yesterday. So we're going to find our x-intercepts today, and we're also going to find the y-intercept today. Now the calculator piece, though, can always be used as a double check. Come test time, though, the work we show today will be the same work I expect to see when you take your test. Okay, the calculator is going to be our tool to double check. It's not going to be our main means for getting the graph. And I'll show you today what I mean by we can use it to double check. So let's start off with part A. It says we want to give the transformations. Hopefully by now, with the work we did in our first lesson with graphing and the practice you did on the first assignment, hopefully the transformations are starting to get there for us. There will not be any notes used on your test because the main thing that we're testing on is what you see before you. So there's not going to be a ton of pieces to this test. It's going to be the main focus is going to be this graphing piece. All right, so our transformations. Those of you that I've helped with this, I've suggested, hey, work your way left to right. Start with the number in front of the squared term. So I take a look at the number in front of the squared term, and it's a 2. 2 is bigger than 1. So if the number in front of the squared term is bigger than 1, what does that make my graph do? It makes it go up faster, but it also makes us stretch. And the number in front of the squared term makes us stretch if it's bigger than 1. All right, the next thing I come across, again, I just work my way left to right. Next number I come across is inside the parentheses. I'm adding. Inside the parentheses, remember, it's always opposite of what we think should be. So this one, it doesn't really go right. It goes to the left. We're going to go to the left one. It's opposite of what we think. We see a plus, and to us, plus should be right, but we've graphed it. We've seen it ourselves. We've made a table of values. We've graphed it on the calculator. It goes left. Last but not least, maybe I can sneak my arrow around the other way here. There we go. We've got a -8 after the squared thing. It's outside of the term that's being squared. And that sign does exactly what we think it should. It makes us go down 8. Now, you don't have to draw those arrows. I'm not expecting to see that on an assignment or a test. But I'm just showing you, here's the piece of the equation that causes that transformation. So if you're like, Miss Golly, I don't see what are you saying it's stretching for? What's making it stretch? What's making it go left? Those are the different pieces. Now from that, your vertex, I don't need to jump to the calculator to try to look at my table to find the vertex. The transformations get us the vertex. Remember, the first part of the vertex is your x. X on the graph is left to right. So if I look at my transformations, we're going to the left one. So if I go to the left one, it's going to be a -1. Then the y part of the vertex is my up or down movement, because the y moves up and down on my graph. And my up-down movement is a down 8. Since it's down 8, it's going to be a -8. So no calculator required at all so far. So based on my transformations, I can get the vertex. A lot of us I know have really been working on getting the right numbers for the axis of symmetry, and then in a little bit we're going to look at the range. Remember, the axis of symmetry is a vertical line. I have to have x equals there because I need the equation of a line. And it tells us x equals. So I need an x value. It tells me x equals, so I need the x value from the vertex. It says x equals, so I need x. Then the next piece, I want to know what my graph's going to look like. Is it going to open up and look like a U shape, or some people call it a smiley face? Or is it going to open down and look more like a frown, is what somebody said in one of my other classes. I kind of like it. Down and frown rhymes. What's the only thing that's going to make my graph open down? What's the only transformation? Is when it reflects. Yeah. Do we reflect here at all? No. So if there's no reflection, you're going to open up. A vertical reflection is going to be the only thing that makes us open down. The domain, you can write the phrase all real numbers, or if you want to try drawing the R, if you just put a capital R there, I know what you mean. Now for the range deals with Y. If we're opening up, this is why I have you pick out the upper down part, is so you can better identify your range. If you open up, that means all of your graph is up above your vertex. If your graph opens up, that means your vertex is that low point on your graph. Everything else is going to be above it. Now, if you need to pick out your range after your graph because you need to see if the graph is up above or down below, that's okay. You could do the range after your graph too. Now, since the range is Y, I need the Y value from my vertex. So let the labels help you. When I was helping a few people the last few days on that first assignment, like, Miss Golly, I know the axis of symmetry and the range, they each get a number from the vertex, but how I can't remember which one. Let the labels help you out. Axis of symmetry is labeled with X, so you need the X from the vertex. The range is labeled with Y, so you need the Y from the vertex. So far, nothing new. It's what we've been working on all week. Now, the new piece, though, we're not going to jump to the calculator and get us a table to make a sketch. We're going to find the x-intercepts. Oftentimes, we talked about this day one, oftentimes your x-intercepts for a quadratic are referred to as the zeros. Day one of this unit, we define the x-intercepts. We said it's where the graph intersects or crosses the x-axis. So if I want to find the x-intercepts, it's where they cross the x-axis. That's the left to right one. On that whole axis, the y value is 0. No matter what point I pick on that x-axis, the y value is 0. So we're going to put 0 in for y, put 0 for y, and solve for x. So if we want to know the x-intercept, we put 0 in for the other variable. And that's exactly what we're going to do. So my equation that I have, the only thing I'm going to change is I'm going to put a 0 for y. So 0 equals 2 times x plus 1 squared minus 8. That's the only thing that's going to change. If you're like, Miss Guy, where'd you just get that equation from? It's right up by number 1. It's what we picked our transformations out of. So the only change I've made, I put a 0 in for y. Now this is what we worked on yesterday, solving equations that have that square in them. And what we talked about yesterday was we need to get the squared term. Whoops, that top line isn't great. Let me try that again. We need to get the squared term by itself first. Oh, that 2 isn't in there. Let me try that again. Here we go. So whatever's being squared, we need to get that by itself first. So the only things that are being squared are the x plus 1. Not the 2, not the negative 8. Now, we use our same old inverse operations that you guys use to solve all of your equations or inequalities during the first part of this course. So if I want to solve that equation, I have to undo the addition and subtraction first. So I'm going to undo minus 8 by adding 8 to both sides. I'm going to undo subtracting 8 by adding 8 to both sides. You don't have to draw the box around the squared term like I do. I'm just making it my focus that I'm not touching anything inside of that box until it's all by itself. Now, yesterday we talked when we were solving these. I know it's really tempting. You see the 2 in front of a set of parentheses. You're like, hey, let's distribute that. I can't because of the squared. Order of operations would say I'd have to take care of the squared first before I can multiply by 2. So instead of trying to multiply by the 2, let's undo multiplying by 2. Let's do that inverse operation. To undo multiplying by 2, we're going to divide by 2. So on that right side, the 2's, you guys, just simplify. There's no distributing. To undo multiplying by 2, we're going to divide by 2. There's no distributing. So what I now am down to is my squared term, x plus 1 squared. Now I know last unit when we saw something like x plus 1 squared, we wanted to multiply, whether it was boxes, parentheses, whatever we liked. That's going to give us a big mess. So yesterday we said, hey, what could we do to undo a square? And we came up with the square root. To undo a square, we take the square root. So all that happens on that right side, the square and the square root, they undo each other. They're gone. Now, yesterday when we talked about solving these, we said that we could really square positive 2. We could really square positive 2 and get 4. But we also saw, though, yesterday that we could square negative 2 and still get 4. So I can square positive 2. 2 times 2 is positive 4. But I can also square negative 2. And negative 2 times negative 2 is also positive 4. So when we're solving using square roots, just like when you solved with absolute value in the first part of this course, you're going to get 2 solutions most of the time. Most of the time. So now all we have to do is finish this off. Subtract 1. 1 equals x. Subtract 1. Negative 3 equals x. So those are the 2 places where our graph will cross the x-axis. And I'm going to go ahead, I know I don't have any room left right here. I'm going to go right up here underneath the sketch part. I have 1 for the x. We put in 0 for the y. I have negative 3 for the x. I put in 0 for the y. Writing those as ordered pairs might make it that much easier for you to graph them. So we're going to find our pieces and then we're going to put our graph together. When you go to do these on your own, you can put the pieces up on your graph as you go if you want to. And we'll try that with our next one. We'll put the pieces up as we go and you can kind of see which way you like. All right, so if to find x-intercepts we put 0 in for y, how do we find the y-intercept? Where's the 0 going to go? In for the x. So we're going to put 0 for x and solve for y. Now the y-intercept is way less involved. I'm even going to show you how you can use your calculator to make this a lot simpler. So here's our original equation. Here's our y equals, here's the 2. Instead of x, we're going to put a 0. Now, if you want to work your way through the order of operations there, you sure can. I'm not testing you on, though, if you know your order of operations. I'm checking to see if you understand how to find the y-intercept. Understand to put the 0 in for x, solve for the y, and then where that goes on your graph. So if you want to, I'm going to jump to my calculator here, and even the basic calculators I have up on the cart will work. You don't need a graphing calculator for that. So we have 2 parentheses 0 plus 1 parentheses squared minus 8. And even if you just use one of the basic calculators off my card up here, there's still parentheses you can use. And I believe there's a squared button too. If not, you can use the little caret key, that little up arrow. So you don't have to have a graphing calculator for this part. We press enter, and we have a y-intercept of -6. So y equals -6. If we want to make it an ordered pair to make it easier to graph, we put 0 for x, and we solved and got -6 for y. So without having to rely on the graphing calculator, we don't need a specific graphing calculator. And to be honest, we really wouldn't need a graphing or a calculator at all to find the y-intercept. We're just using it to make it a little quicker for us. Let's graph all our pieces. So here we go. I'm going to start with the vertex. So -1, -8. Axis of symmetry just goes right through there. And the axis, I know some of us haven't seen the value in the axis yet. We're going to see it today. We're going to see the value of that axis today. All right, so we graphed vertex, we graphed axis of symmetry. X-intercepts are at 1, 0 and -3, 0. Notice they're on the x-axis. That's our horizontal one. And then the y-intercept is at 0, -6. Now you might be thinking, okay, Miss Golly, I can kind of see that U shape there. It looks like what we've been graphing. But it doesn't quite look symmetric because I've got 2 points on the right side of that axis and I only have 1 over on the left. So there's where we can use our axis to even things out. So I've got this point on my y-axis. I just need to reflect it over. I need the mirror image on the other side. So that y-intercept is 1 away from the axis. So on the other side of the axis, there's a point that's also 1 away from the axis. So there's where the axis of symmetry comes in handy. It can help me find more points without doing hardly any work at all. So now I have a beautiful looking graph. Now, if you want to, you can enter that equation. I want to show you how you can check on your test. I'll let you use graphing calculators on the test. I have no problem with that. So we can enter in 2 parentheses x plus 1. Use the squared key. Some of you I was helping the last few days. You're still using the caret key. Use the square key. It just cleans things up. It makes it a lot simpler. We don't have to second guess what needs parentheses and what doesn't. And then we have a -8. So what this can help you check is if you just press graph. Oh, mine is all goofed up. Just kidding. There we go. if you press graph, you can check to see if the graph you created looks like the graph on the calculator. It looks really, really similar. And then what you can also do, you know where the vertex of your graph is. We are at -1, -8. Go to your table and double check your points. There's -1, -8. There's our 0, -6. There's 1, 0, and there's -3, 0. So all the points that we just put on our graph that we found are all right here. So if you need to double check yourself, this tool can do it. But to get credit on your test, I need to see that you can find those. Solving those little equations using square roots and how to find the y-intercept. Okay, so again, this is the double check. If you want points on your test, I need to see the work that we have here. Okay, and it needs to match your graph. It can't be, I'm going to put some work down and then I'll just have the right answer from the calculator. Calculator is a tool that's going to help us check. All right, let's try another one. This one's a little less involved. I wanted to make sure we saw one like this because this one, it only has one transformation, and that's okay. That's okay. For some of you, as you were working with the transformations this week, some of you were trying to always put down a stretch or a left-right and an up-down. You were always trying to put like 3 or 4 transformations for each graph. Not all of them will do every transformation every time. This one, for example, there's not a number in front of the squared term. But now inside the parentheses, though, we're adding. So we do go left 4, but then there's not a number outside the parentheses, so there's not an up-down. The only transformation is left 4. That's it. And that's okay. It doesn't, your graph isn't always going to stretch or reflect or compress or move up and down. It's not always going to do all those things. So now when I go to find my vertex, my left-right movement is first. We go left. And then if there's not an up or down movement, that means the up-down piece hasn't moved from 0. Same thing would go if there's not a left or right movement. The x part would be a 0. That's okay. It's not going to do everything all the time. Axis of symmetry, x equals the x value at the vertex. We did not reflect, so we're going to open up. Domain all reals, as always. The range deals with y. If your graph opens up, all the y values are going to be greater than or equal to your vertex. The y at the vertex is 0. Again, notice axis of symmetry has the x of the vertex. The range has the y. So all those pieces, that's what we've been practicing and working on. And we'll keep doing that. We're going to get lots of practice with those transformations and all those other pieces. Now, to find the x-intercepts, aka the zeros, we put 0 in for our y, and we need to solve for x. Now, if you're one of my people where it's easier for you to solve equations if the x is on the left, you can switch it around. This is an okay move if that's going to help you solve. If you're better at solving equations, because I know, guys, when you guys first learn to solve equations, the variable, for some reason, most teachers always put it on the left, and that's where they leave it. So it's kind of how our brains get programmed, that it's easier for us. So if you need to switch it around to get that x on the left, that's okay. Just don't change any signs or anything. Just switch the two sides, if that helps you. All right, so the squared term, it's already by itself. There's nothing to add or subtract away. Now you might be thinking, Miss Callie, but there's a +4. Don't I have to move that? I can't yet because it's part of the squared term. It's part of what's being squared. So, to undo the square, we square root. The square root on that left side just literally undoes the square. It does nothing else. It doesn't change the x. It doesn't change the 4. All right, so we've got x plus 4 equals, now up here, I had to take my 4 and I made a positive 2 and negative 2. Can I do that with 0? Can I make 0 positive and negative and it's going to be a different number? No, I can't. So for this one, we just have 1. And that's okay. For this one, we just have 1. So all I can do on this is subtract 4 from both sides. X equals negative 4. So my x-intercept, if you want to write it as an ordered pair to make it easier to graph, no problem. I might be thinking, Miss Golly, negative 4, 0. We already found that. You're right. If your vertex, here's negative 4, 0. If your vertex is on the x-axis, that's the only x-intercept you're going to have. Because that is my middle point. There's not going to be another point on the other side of it. There can't be. There's not another side to it. It is my middle. It's where my axis of symmetry goes through. So if your vertex is on the x-axis, the vertex and x-intercepts are one and the same. The x-intercept is where the graph crosses the x-axis. Now, if you recognize that, I don't need to see all that work for the x-intercept, if you recognize it. But if you want to double check yourself, you sure can. Now, the y-intercept, though, that's how we're going to get more points on our graph, because right now, I just have 1 point, and 1 point doesn't give me a very good parabola. So to find the y-intercept, we put 0 in for our x, and we solve for y. This one I'm hoping is no calculator needed. We just end up with 4 squared. Our y-intercept ends up being at 16. Now, I know for some, you're like, Miss Callie, but 16 won't fit on my graph. We had this issue with our exponentials, and it can also happen with quadratics, where sometimes the values we get are just, they're too big to keep our scale going by ones. So instead of our y scale going by ones, let's make it go by twos will fit. So each line is going to be worth 2 instead of 1. So if you come across a value, whether they're x-intercepts or y-intercepts, if you have a value that's bigger than 10, because our graph only goes to 10 positive and 10 negative, change your scale so it fits. It's a really simple thing. It's nothing to panic about if a value won't fit on your graph. We're squaring things, so when you square things, they have a tendency to get bigger kind of fast. All right, so y-intercept is at 0, 16. I'm going to make this red so I can see it better. So now, right now, I only have 2 points on my graph. That's not going to give me a very good idea of my parabola. So let's use that symmetric property. My y-intercept is 1, 2, 3, 4 away from the axis of symmetry. So on the left side, I go 1, 2, 3, 4 away from the axis of symmetry. If you can give me 3 points, we can still do a decent sketch. 2 points won't work. I can't just graph that vertex and y-intercept and call it good. I need to use that symmetric property and get a point on the other side. So far we've seen, I look at number 1, we have a graph that had 2 x-intercepts. We've had a graph that's just had 1 x-intercept. And when that happens, it's the same as your vertex. Our third and final example. I want to get you guys some time to practice. And you're more than welcome, guys. I'm going to start writing the transformations up here. You're more than welcome to try them out yourself. I'm going to start picking away them up here. Hopefully at this point we're getting pretty comfortable with them. If not, we'll have some more practice time. I'm just going to draw the arrows so you know why I'm putting what I'm putting. So you know why I'm putting what I'm putting. I'm going to draw the arrows so you can see what part of the equation is causing that transformation. You don't have to draw the arrows. Again, I'm just drawing them. I'm just drawing them so you can see why I'm putting what I'm putting for those transformations. So what part of that equation tells me my graph is going to reflect? What part of the equation tells me I'm moving right 2? What part's telling me I'm moving down 1? I work my way left to right. Don't jump around. When I was helping some of you this week, some of you like to try to you work your way backwards, or some of you start with what's in parentheses. I like to work my way left to right so I don't forget anything. If drawing the arrows helps you, so you have every piece of the equation connected to a transformation, not a bad idea. All right, so from our transformations, we can get our vertex. The vertex is the left or right movement. So we're going right 2, so we're going to be a positive 2. And then the up-down movement, we're going down 1, so we're going to have a negative 1. Axis of symmetry is always x equals. The label x tells me I need the x value from my vertex. This graph does reflect, so we will open down. The graph does reflect, so we will open down. Domain, all reals, every time. The range with y. And again, if you need to wait to see your graph to decide if it's a greater than or less than, I know a lot of you with the exponentials, it helped you to see that the graph was up above or it was down below the number you were looking at. That's okay if you need to wait and look at your graph. That's okay. If we're opening down, that means all of our y values are going to be less than or equal to, and we need the y at our vertex. We need the y. It's labeled with y. It's telling me which piece to use. All right, the x-intercepts. If I want to find the x-intercept, 0 goes in for y. Zero goes in for y if I want to find the x-intercept. You don't have to draw this box around. I like to, because I know everything inside of that box. I do not move. That's what I save for the end. That's what I'm going to take the square root of to then help me finish finding my intercepts. So from here, same old of how you solve an equation. Don't let the square bother you. Undo addition or subtraction first. Undo addition or subtraction first. You don't have to draw the box. It helps me know that I'm not touching anything inside of there. I'm not going to try to add that 2. I'm not going to try to distribute that negative. Nothing inside the box is going to change until the last step when I do the square root. I really wanted to make sure we saw one like this, where there's just that negative sign out front, because we come across those quite a bit when we graph. What number is really in front of there? A negative 1. So it's negative 1 times our square. So to undo multiplying by negative 1, we divide by it. So the negatives will simplify out. You do not distribute it. Another reason why I like to draw the box there. What's inside that box, that square term, doesn't change. The only thing that's going to change it is when we do the square root at the end. So now I have negative 1 equals x minus 2, that quantity squared. All right, I've got the square by itself, so let's square root. We talked about this one yesterday, but for those of you that weren't here, I want to make sure I refresh on it. The idea with the square root is we're trying to find what number times itself will give me negative 1. Well, if I look, for example, on the first one we did, when we were looking at 4, well, what number times itself can give me 4? Positive 2 and negative 2. Positive 2 times 2 gives me 4. Negative 2 times negative 2 gives me 4. With 0, well, the only number I can square to get 0 is 0, so that's all we could put. Now with the negative 1, though, what number can I square and get a negative 1? Can I do that? What do we need in order to get a negative? We need a what times a what? We need a negative times a positive. If I'm squaring something, can I do a negative times a positive? No, I can't. Now, if you need more verification than that, again, especially for those of you that weren't here yesterday, if I do the square root of negative 1, my calculator is going to tell me it's an error, and it's correct. There's not a real number that I can square and end up with a negative. I can't, because I need a negative times a positive. So when this happens, this is a no solution. There's no x-intercepts. And that happens. We're going to see our graph in just a minute. We're going to see that this graph doesn't cross the x-axis. And that's okay. It happens. So now we're really stuck. We don't have any x-intercepts. So far, all I have is a vertex. I'm hoping our y-intercept works out. So we have y equals negative 0 minus 2 squared minus 1. Now, all those negatives, all those minuses, guys, throw it in your calculator, okay? I don't want us to be calculator-dependent kind of people, but when it's something that I'm not trying to test you on, your order of operations, I'm trying to see if you can find the intercepts of a graph. Minus 2 squared, and we have a minus 1 off the end. So my y-intercept is negative 5. All right, so what we have to graph, we have a vertex, 2, negative 1. Axis of symmetry is going to be helpful for us to find another point to help us make our graph. Y-intercepts at 0, negative 5. Here it is. 0, negative 5 is 1, 2 spaces away from that axis of symmetry, which is the middle. So I need another point that's 1, 2 spaces away on the right-hand side. So notice our graph doesn't cross the x-axis. Our graph doesn't cross. And again, you guys can enter these things into your graphing calculator to verify, yep, I've got the right graph. You can go in and look at the table and make sure you've got the right vertex, you've got the right y-intercept. But I'm going to need to see the work, though, that's up here come test time and on your assignment, too. Okay? So I want to give you guys some time to practice.